everyone, I am Varsha.
And I am Manaswini, and we are excited to present our project titled Experimental and Numerical Investigation of Cold Form Steel C-lipped sections with multiple perforations using piezoelectric sensors and Python GUI analysis.
In simple words, we use smart sensors and a Python based software to detect and simulate damage in lightweight steel sections. Let's dive in.
Cold form steel is commonly used in modern structures because it's lightweight and strong, but damage over time can be dangerous. That's why monitoring its health is so important. Instead of traditional methods like visual checks, we used the electromechanical impedance or EMI technique. Two piezoelectric sensors were bonded to a steel seal-lipped section, 18 cm apart to monitor changes. We tested the section in its undamaged state first using an impedance analyzer between 30 to 400 kHz. Then we introduced damage in 4 stages, drilling 2, 4, 6 and finally 9 holes and recorded the EMI response after each stage.
After every stage, we calculated RMSD values to quantify how much the signals changed. This helped us measure how severe the damage was. Now let's talk about the cool part, our Python GUI. We designed a graphical interface that simulates how EMI responses change as damage increases. The GUI allows user to select how many holes are present, that is 2 to 9, and generates conductance frequency plots using baseline functions with random noise to simulate real behavior.
It even shows how a dynamic heat map of damage intensity and calculate RMSD values, just like we did experimentally. This made it easy to visually compare real and simulated results.
The GUI also includes the material properties of cold form steel and piezoelectric sensors, making the simulation more realistic.
Results and discussion. Our experimental data showed clear trends. RMSD values increased with more damage. The highest RMSD, that is 13.2%, was observed at the 6 hole stage, indicating severe damage.
Interestingly, the GUI results followed the same trend, which validated our simulation model. It improved that both the hardware and software together can accurately monitor damage.
We also observed that EMI is very sensitive even to minor structural changes, making it a great candidate for early warning systems in steel structures.
To sum up, our study successfully combined experimental EMI sensing and a Python based simulation to monitor damage in CFS sections.
EMI technique worked reliably for detecting damage. RMSD was a great indicator of severity. The GUI masked real data, giving a powerful visual tool.
Looking ahead, we would like to improve this system for real time monitoring, add fatigue crack detection, and maybe integrate machine learning to classify damage patterns automatically.
We hope you enjoyed this overview of our project.
Feel free to ask questions or reach out if you would like to know more. Thank you for watching.